It is time to look at symmetry and to determine whether a graph is symmetric with respect to the x-axis, the y-axis, or the origin, and then determine if a function is even, odd, or neither. Now, it's funny when, I first started studying algebra and, talked about symmetry, and something that maybe you can relate is they always say very beautiful people are symmetric, meaning, like they don't have one eye bigger than the other. I know that's not funny, but it's kind of weird, right? If you cut them in half, the right side of their body looks just like their left side of their body. That's the same thing we're talking about here with symmetry. And so you can actually look at by considering with points. So notice here for 2 and then for -2, notice that the 2 became negative that appear on the graph that we're going to see on the next slide. But these points like these have the same x value but opposite values for y. It's called a reflection about the x-axis. And so if any point xy on a graph and then also the point x negative y, it's symmetric with the x-axis. And so this is what it would look like. If I cut, like just took a knife and cut right here on the x-axis, this side looks like a mirror of this side, and that's pretty much it. You can definitely look at reflection about the y-axis. Notice what changed was the x value, and it's easier to see here. So the x value the y value didn't change, but the x value went from +3 to -3, and we could see if I cut it right down the middle that the left side looks like a mirror of the right side. You can do this for many different points, and even looking at, well, what if both the x and the y changes signs? And then in this case, it's symmetric with the origin. So it looks like you put a mirror here. Remember the origin at 0, 0, and this looks like a mirror image of that. There is a way to test these without just graphing. Algebraic test of symmetry, the x-axis. You will see when you work through these, you replace y with -y. If it produces an equivalent equation, then it's symmetric with respect to x. Same thing with the y-axis, but replace x with -x. If you get the same equation, it's symmetric with the y-axis. And then the origin, you replace both x and y with negative. So you might see an example like this to see if x squared plus 2, if it's symmetric with which axis. So to test it with the x-axis, we replace y with -y, and I could divide both sides. In this case, you can see that I'm dividing by negative here. The resulting equation is not equivalent to the original, so it's not symmetric with respect to the x-axis. I can do the same thing here with the y-axis, replace now x with -x, but notice when you square -x, you get back the same equation, so it is symmetric with respect to the y-axis. And then even looking at the origin, replacing both, you do not get the same, and you can kind of see this once again. It's always best to graph these, and that leads us into even and odd functions. So if we have the graph is symmetric with respect to the y-axis, we say that it's an even function. So this is where we were plugging in -x, and in this case the -y. If the graph is symmetric with respect to the origin, we say it is an odd function. So once again, you can kind of see that when you're given a function, you first find f of -x and simplify it and see if they're equal, then it's even. Then you put the negative on the outside, compare it with the f of -x from this previous step, and if these are equal, then it's odd, and it looks like this. So determine whether the function is even or odd. The first thing I do is I plug in -x everywhere, a -x. And so we can see that this certainly changed. The function is not the same. So f of x is not the same as f of -x, so it is not even. if I put the negative on the outside of the function, so I distribute the negative completely through, we can see that f of negative x, okay, so going back to, oops, sorry about that, going back here, my f of negative x, we can see that it is actually the same, so it is an odd function. And once again, the thing to do, graph it. So if it, in this case, is odd, it looks like we put a mirror on the origin and the left side is a mirror of the right side.